Welcome back to the channel. In this video, we are going to understand why normal distribution and skewness matter in data analysis and how they impact the way we interpret data. I recommend watching this video 2-3 times so that these concepts really sink in and feel second nature. Understanding normal distribution and skewness is a key part of exploratory data analysis (EDA) because it directly influences how you choose features, select models, apply transformations, and improve prediction accuracy. Many machine learning models assume that your data follows a normal distribution, which is why it is essential to visualize the data and check for skewness. Simply put, this helps you identify outliers that may be impacting your dataset and decide whether any transformation is needed for your variables. This video is especially helpful for anyone looking to understand these fundamental concepts, even if you are not directly working in machine learning.
Alright, let's take a quick look at this chart. It shows how often people go out to eat in a month. Now, this curve you see here, that's called a normal distribution. It's basically a bell-shaped curve that's nice and symmetrical. Most people fall somewhere in the middle, and only a few are out at the extremes. Let's break down the lines. First, the red line on the left is called Q1 or quartile 1 or the 25th percentile. That means 25% of people dine out less than this number. So it's kind of like the lower quarter of the group. Then we have the green line in the center. That's the median or Q2. It splits the data right down the middle. So half the people dine out less than this and the other half dine out more. And finally, the purple line on the right is Q3 or the 75th percentile. 3 out of 4 people dine out less than this point. Only the top 25% dine out more frequently. So this chart helps us see the bigger picture. Most people tend to dine out an average number of times, and the bell curve shape shows us how the behavior is distributed. Next is standard deviation, understanding spread practically. So let's break down this normal distribution using a real example, the dataset 2, 4, 4, and 6. We have plotted these 4 data points on the classic bell-shaped curve, also known as normal distribution. The mean or average of this dataset is 4. That's right at the center of the curve, marked with bold red dashed lines. Also, in this particular case, the median is also 4, since it's the middle value when the numbers are sorted. So we have got a nicely balanced data set here, symmetrical and centered. Now look at the individual data points. The blue dot on the left is 2. It's about 1 standard deviation below the mean and still well within the bell curve. We have got 2 4s, both sitting right at the center. You will see those dots stacked on top of each other at the peak of the curve. Then we have got 6 on the right, which is 1 standard deviation above the mean. What's interesting here is that all values lie within plus minus 2 sigma and most lie within plus minus 1 sigma, which is exactly what we expect in a typical normal distribution. Around 68% of the values fall within 1 standard deviation. We have also marked Q1 and Q3 on this plot, so 3.5 and 4.5, which help define the interquartile range, the range where the middle 50% of values lie. So even with just 4 data points, this simple data set gives us a clear visual of how values can spread around a mean in a normally distributed pattern. and why standard deviation is such a powerful tool to understand variation. Moving to very important concept in stats, checking skewness in your data. And here we are looking at a left-skewed distribution. So imagine this data set represents how often 15 people dine out in a month. You can see their values listed here: 0, 1, 2, 3, 4, 5, 6, 7, 7, 8, 8, 8, 9, 10, and 11. Now check out this histogram and the curve over it. The shape gives us a lot of information. You will notice the tail is on the left. That means a few people rarely dine out, like once or not at all. That's why we call this a left-skewed distribution. Let's look at the key statistics. Mean is about 5.93, median is 7, mode is 8. Now here is something interesting. Mean is less than the median, and that's a classic sign of left skew. The rare low frequency diners are pulling the mean down. Also notice the spread. Standard deviation is around 2.78, variance is 7.73. At the bottom of the slide, you will see Q1 and Q3, the first and third quartiles, which also tell us how spread out the values are. So what does this all mean? Even though a few people dine out very rarely, like 0, 1, or 2 times, most people still dine out frequently, around 7 to 9 times. That cluster pulls the mode and median to the right, but those few rare diners on the left shift the mean downward, giving us this left-skewed shape. This is why understanding skewness is so important. It tells us whether the mean truly represents the center of the data or if it is being dragged by outliers. Let's now look at the other side of skewness. This time we are dealing with a right-skewed distribution. Again, imagine 15 people and how often they dine out in a month. The data set is 1, 2, 2, 3, 4, 4, 5, 6, 7, 8, 10, 12, 15, 18, and 20. Looking at the histogram, what stands out? The tail is on the right. That means a few people dine out a lot. Maybe they are food bloggers or just big foodies. Now here is the summary. Mean is about 7.8, median is 6, mode is 2 and 4, both occur frequently. Notice the pattern. Mean is greater than median. And that's your classic signature of a right-skewed distribution. Also, check the spread. Standard deviation is a whopping 5.56. Variance is 30.9, both much bigger than the left-skewed example we saw earlier. So this data is quite spread out. The quartiles Q1 4, Q3 equals to 8 show that 75% of people dine out up to 10 times. But those extreme values 15, 18, and 20 pull the mean to the right and widen the spread. So what is the interpretation? Most people dine out 2 to 6 times, but a few are really pushing the upper limit, maxing out their food budget and shifting the average up. This is why understanding skewness is critical. Without it, you might think everyone is dining out 8 times a month, when actually most are well below that, and just a few outliers are distorting the picture. So in this video, we looked at the normal distribution. Next, we explored skewness, both left and right, and saw how outliers affect the mean. In our previous video, we started with the central tendency of data, exploring the mean, median, and mode. Later in the same video, we understood how variance and standard deviation help us interpret the spread of data. With all of this statistical foundation in place, we are now ready to move into the exciting world of data visualization techniques, where we will actually see these patterns come to life. Till our next video, keep learning and growing.